Welcome to the Punny Math Teacher. So for expectations, remember to use twice the video's length to take notes and wonder. Take your time. You can always pause, go back, go forward, change the playback speed. And these are notes to your future self, so make sure that you can read them. They are for you. And then my website is there for extra resources and help along the way. So today's objective is to apply the distributive property. Last one in this little mini unit on my website. All right, moving on. So, page 6, distributive property to simplify. Remember, if I go too fast, pause the video. You have the time. Go for it. Distributive property to simplify. Make sure that's all headed up on your paper. We're going to do 2 little columns at the top, and then we're going to move into 4 boxes on the bottom, and we're going to do brown and orange, because that's what my master key is for. Okay. So we're going to write a list of what it means to simplify, or how do you simplify, and then we're going to go over the distributive property in this column. All right, so to simplify, one of our goals is to get rid of parentheses. At the end goal, we should have at the end expression, we should have no parentheses at all. We should have only one term for each variable. So, i.e., we're combining all of our like terms. So, as a reminder, like terms have the same variable and same exponent. And then we also are going to want to make sure the fractions cannot be simplified further. That means the numerator and denominator will only have a common factor of 1. That's okay. That means they are both relatively prime, and we can't break it down any farther. So distributive property, we're going to go over why it works and what it is. So I want to do the why first. So why it works. I'm going to start with 16 plus 20. And note that this is 36. But 16 and 20 have a number in common. They have a factor in common. What number can go into 16 and 20? 4. So if we rewrite this, 16 is the same as 4 times 4. And 20 is the same as 4 multiplied by 5. I've made changes to how this equation looks, but I haven't changed the value of anything. 16 is still 16, 20 still represents 20. It's just now 4 times 5. It looks different, but it's the same. I can actually factor this out, and this is still the same equation. I've now moved 4 outside because I noticed they both had a 4 in common, so I'm going to add the 4 and the 5, but I'm going to pull that 4 out, because now I have 4 times 9, and that gets me 36. So I can write all 4 of these equations. They're the exact same thing. It equals 36. I had the 16 and the 20. I've just rewritten the left-hand side to make it look special. The distributive property is what changes this third line into the second line. That's the distributive property. So the what it is if you see 4 times 4 plus 5, I'm going to distribute that first 4, this outside one, into everything inside, because this parenthesis means to multiply. So I'm going to multiply the 4 times the 4. Then I have to add, because there's a plus sign in between. I'm going to then add 4 multiplied by 5. I'm distributing that outside 4 into both terms in the quantity 4 plus 5. That gets me 16 plus 20, and that gets me 36. So notice that I have no more parentheses. I only have one term because all of these are constants. So there's only one like term at the end, 36, and there are no fractions. So, I mean, technically it's 36 over 1, which that's as simplified as it can get. So that's me using the distributive property. I distributed the 4 to each term in the parentheses. we're going to do 4 examples. And this is mostly geared toward equations, which is our next unit that I'll be recording for. So we're not going to see many. Okay, we're going to see some. But I want to mention that this is mostly useful for variables. So it seems really redundant or dumb when we're looking at it with just constants, but using it with variables is really helpful when we don't actually know what all the numbers are. So our first example will just be 2x plus 3. Then I'm going to write these 2. Yeah, well, yeah, we'll just stick with those 2 for right now. All right, so these top 2, this one doesn't look like it has to be distributed by anything, but I do want to point out that if you see nothing in the front of parentheses, that means there's an invisible positive 1 there. This positive 1 does get distributed through, and what do you end up with? 2x plus 3. Because 2x times 1 is still 2x, 3 times 1 is still 3, so it's an invisible 1, but I'm actually going to end up with 2x plus 3. Now, in this second example, we see the negative sign, and you're right, this is an invisible negative 1. So I am going to write out all of this work. When I do this first rainbow, I'm going to have negative 1 multiplied by 2x plus negative 1 multiplied by 3. So think about where the 2x and the 3 came from, where the negative 1 come from, why did I do rainbows, and where did that plus sign come from. Negative 1 multiplied by 2x is negative 2x. Negative 1 times 3 is a negative 3. You could write it as plus negative 3. That would work. And then those are as like terms as I can get because that's an algebraic term, that's a constant, so I'm stuck. All right, so notice how this positive 1 keeps the signs, the positive 2x, positive 3. The negative 1 makes the opposite sign, so it's a negative 2x and a negative 3. All right, so this one I kept signs. This one I changed signs. Whoop, gonna mark my nail up. All right, and then 2 more examples. So 5 times 11 plus 25. So it's 5 multiplied by this whole quantity. And now we are going to do a fraction one. Okay. So 5 times 11 comes first. So I'm going to write 5 times 11. I use the rainbows with these arrows to keep track of which one I've done when. Sometimes you can get really long expressions with distributive property, and I want to make sure that I'm still doing everything in the right order and not skipping or doing twice something else that I should have only done once. And then 5 times 25. 5 times 11 is a repeat, so it's going to be 55. 5 times 20 is 100. 5 times 5 is 25, so this is 125. So if you've been noticing, I'm doing this 5 times 25. I always break down the place value, so it's 5 times 20 plus 5 times 5. That's how I'm getting that 125. And my answer would then be 170. Nope, 180. There we go, 180. And then for this one with the fraction, I'm going to distribute. So I'm going to get negative 2/3 multiplied by 6x plus negative 2/3 multiplied by 12. Notice how the 6x and the 12 are staying in the numerator position. If it helps, put them over those invisible ones so you make sure all your numerators line up, all your denominators line up. Now we can actually simplify. I'm going to use my pen because it's skinnier, different color. 6 and 3 have what common factor? 3. So 6 divided by 3 is 2. 3 divided by 3 is 1. No other numerator denominator pair, so this actually simplifies to just negative 4x. 12 and 3, that's a 4 and a 1. So that gets me negative 8. And that's as simple as it gets. I have an algebraic term and a constant. They are not like terms, so I am stuck. So this is helpful when we move into variables with equations, which is our next unit. But yeah, all right. We did the why, we did the what. Make sure you've gone over this, and then our discussion questions for today Pause this. Why is it called distributive property? Do those rainbows or arrows help you? You can call them whatever you want, but if they don't help you, what does? And then how can you tell when an expression is fully simplified and you're done? You have no more work to do. You can't go any farther. So how do you know that? And put that down in your notes. That way you know later, hey, I have to go look at that and make sure that I completed this question. So thank you for watching and have a great day.